Nobody. The same question for geography and geometry. 1. Respect. Hierarchy. Hierarchy, no hierarchy. Vacha, Max? Flexible? This is a different thing. So this is the actually from all this limitations, this is the biggest one. We had to deal with it, but there is a workaround. We're developers, you will find a workaround. In this case, so it's feasible. And this is from development point of view, from integrity point of view. This is the no alter table. You create a table, that's all. Sorry, you have to drop it if you want to change it.
Just
think in advance what you need, what you would need, what would be if this change, how frequently you will change the same row of this table. And for those questions you have to ask, you have to talk with managers, and they usually don't have a clue about data volume and such things. Drop quit, no constraints. In CTP2 there was no constraints at all. In RTM you have a default constraints. Thank you, Microsoft. Default constraints you can do. There is no check constraint, there is no foreign keys. If you don't have a foreign keys, what's the problem with it? Then it's fast. I have even some developers who just make tuning of removing foreign keys. Then it's a little bit faster and script will always work. So no foreign keys means that either we cannot guarantee integrity anymore, which is an option. We can have a system where it's not so important. Not a big deal. If it's important, you have to implement somehow differently. In database, I don't know, application access to be able to provide. It's not provided, and this will not be provided in the second, definitely. This is a feature by design. If you have to check something, I mean, SQL Server has efficient mechanism to check foreign key relationship. But it's more efficient if you don't check it at all. And this is the reason why they just remove it. So you can create index, but together with create table. So you should think not only about table columns and table structure, but also about indexes. If you figure out after some time that you need some index, you have to drop the table. And create it again. If table has, I don't know, 1 gigabyte of data, you have to reinitialize this table. That means you will have downtime. So this is fact. And yeah, this is a attribute will come later. So a lot of constraints, serious things that affect every piece of development. In regular table, in these tables, I always try to force constraints. If one column you can have 1, 2, 3, put check constraint and put possible values 1, 2, 3. There is no reason to allow more. We could do, maybe we will need this later. If we need later, we make alter later. So usually you don't need, because if you don't put the constraint, you will find one day some value 10 there, and you will not know what does it mean. If you just expect 1, 2, 3. Foreign keys, you don't need to explain. So it's serious constraints. That means if someone sees it, it's not for me, I will not use this. So, and which is not so, could be true. So why is all this stuff? Why I have to put this in advance? Because when you create a table and some other database objects in memory, they just create C program for you in the background and convert this to DLL. And link this DLL to SQL Server exit process and put it in memory. This is the most efficient way. So it's done. So you cannot change it because this is linked to SQL Server process. You have to drop it and to create it again. I mean, they can support alter table. They can do it in background exactly this and allow you to make alter table. I'm pretty sure that they will do this in next version. But in background, they will drop it and create it. And just support syntax for us. So that's the reason why. You can find even how this looks like. You create table and you can see some strange code there. This is how Microsoft writes in the background your table. It's not create table anymore. It's not declarative, it's C language, and this is then compiled to DLL, and you can even find this better. So about tables, you can have two options. All data is always in memory. You have to put all tables in memory. If you don't have enough memory, no way to work. Similar as now, if you don't have a place on disk and you need, I don't know, 100 gigabytes, that will not work. So you have two options. One option is just schema only, and schema and data. It means if server crash, or if you restart the server, you will lose your data. That sounds terrible, but in some situations it's not so. I mean, if you can restore this data, it's not so dramatic. Of course, this user data, it's a dramatic thing. So between these two, you can choose, of course, when you create a table. So you cannot just change this later. And of course, this is pretty fast, and this is not so fast. You should not expect something like, I forgot to tell you, Hekaton, whole name means in Greek, Hekaton is 100. Initially, they want to develop something which is 100 times faster than existing solution. And they did not get it. So 50 times, 30 times, but it's impressive. You know, sometimes I tune a query for 1 week and get, I don't know, performance gain for 30%. So if someone just work on this very hard, so I appreciate that something is 30 times, I don't know, faster than I do this in a couple of minutes or a couple of hours. It's impressive. But difference between these two. So that means this data are written in disk. So if your server crashes, you will be able to get this data again. Of course, you have to wait, because that should be initialized. Data are always in memory. You need to wait until all this data from this comes again to memory. Okay, good. So, just summary. You need to predict in advance. This is a real challenge. Also right now, I have 120 developers in my company. Most of them don't know to predict this and don't try to predict. They just create and then we will check it later. And I'm 43 years old, and this later still does not come. So basically, whenever you put something for later, there is forever there. There is no older, and basically it's very, you have to drop the table. If you just come to manager and tell, you know, I would create a new index and then we will have better performance. But I need to drop the table and create it again, and our customers will not be able to query this table within 5 minutes. You can't predict what the answer will be. So it's very hard now with this feature, with no alter table, to do any change. So you have to wait until you create a table. You can play, of course, on that, but final version. So general, if you try to move to Hekaton or to in-memory or TP, first there is a lot of things. You have to find out use case. You have to consider limitations. You have to find workarounds. And then you have to pick some numbers when you design the table. If you pick a wrong number, then you will blame the feature and say, this is stupid. Because this is human to human nature. If some query was slow, and I have put something and now it's fast, then I tell, I'm a smart guy, you know, I'm tuning. If I wrote the same query, and this query suddenly doesn't work, I will not tell I'm stupid. SQL Server is stupid. This optimizer doesn't work. So this is the same as with Hekaton. Expectations, you know, 100 times. Okay, not 100, but 10 times. I expect something. And then, if you pick a wrong number, after you just skip all these limitations, so I can work around here, I choose here, and come here and put some bad number, and you can find situation that your query is slower than before. And then basically it's a frustrating thing, you know. And you want to make this prototype to present to someone, you click and to see that it's basically slower. That means you have to play with this data, you have to be patient with this. Okay? So, indexes. We have two types of indexes. Both indexes are in memory. With one not so, let's say, a stupid name, I don't need to be polite. So you have a non-clustered index and you have a non-clustered hash indexes. And you don't have a cluster indexes. If you don't have non-cluster index, why you have the same name for both of them? So, do you want non-cluster index or non-cluster hash index? So, this is BW index, BW3 index, and basically they use these two names. We don't have, unfortunately, time to do to go to details about indexes. But one of the challenge here is to pick number of these buckets for index. If you miss it, you will be slow definitely. And you will not reach your goal, and even you can be slower than before. So it's a terrible thing. And in the meantime, you have asked management to buy more memory to invest something and then just you pick the wrong number and now it's slower. It's pretty disaster scenario, which is possible. And I saw a couple of them, and therefore people just blame the feature. So the good thing with indexes is they are in memory. So they are not written to disk. They are not written to a transaction log. Hekaton used the same transaction log as these tables. So if you have data durability option, if you don't have data, if you just choose schema only, you don't have to do anything with transaction log, which is of course then fast. Usually you have to write the transaction log and the get signal is commit, and then you get now I'm committed. If you work only in memory, you don't need to touch it. Therefore it's fast. If you have to touch it, it will not be so fast. But it's faster than this table because you don't need to log rollbacks. There's no rollbacks there, and you don't need to write indexes. Indexes are only in memory. So if you create a table from scratch, if you just initialize, indexes are initialized. There's no need to write indexes in the disk. Okay, I have more slides than I have time, and then you can download it here and see some attributes for these indexes. Unfortunately, I don't have time. If I just start with indexes, we will not touch features. So let's skip. You have some other limitations. You cannot perform update statistic easily. You have to use some things. This is this is basically feature of version problem of version 1 that will be fixed, I guess, later. And you have some recommendations. All these things that I skip very fast. If you don't care about them, you will get this situation that you can be frustrated, because when you try to do this, you will get some error. You have to tune a little bit. Whenever you try to execute something, you will get an error first. You have to fix it, and you execute again, and fix another error. And basically, it's frustrating. After some time, basically, you just used to live with this frustration. You just accept it. Okay, I mean, just fix it. But some of them are because this is the first version. Okay. Do you have any question till now? I will continue to go fast, but I will just...
Can you have a mix of the standard disk storage database and some part of your database in memory?
Yes.
Can you have that kind of implementation, or have it in standard way and later you decide to add in-memory?
Yes, we can. The question was, if I understood it, can we combine these tables and memory tables within one database?
Or add it later or something?
Yes, we can. You can just one table put in memory, and you can, with your transfer SQL, with a small set of limitations, we will see them, you can make join between memory table and this table. You cannot do everything. You cannot truncate table or something like that, but usually you can do with transfer SQL, you can catch both. So sometimes if you have a lucky, you don't need to change code at all. You just switch one table from this table to memory and your code will work. So you don't need to put the whole database. You can just pick 3, 4 hot tables in memory, and all the other are basically these tables. So you can combine them. Any other questions? No, thanks. GS SQL interop. This is component which help us to deal with both of this. And there is a special component, native store compile store procedures. This is second point where you can get additional speed. This is a special store procedure where you, similar to table, you create this store procedure in advance. You cannot alter it. You can put everything which is related to the store procedure, and basically from this store procedure is again created C program and then converted to DLL linked to SQL exactly with as table, and this basically allows you the following thing. If you execute this store procedure, your CPU thread gets this to work, and do not just give, you don't give CPU to some other thread. You just get it until the end. You don't need to wait. The whole thing about in-memory tables, in-memory OLTP is not only memory, it's but optimistic, pessimistic. So no waits, no locking. SQL Server is pessimistic tool, pessimistic database system. Whenever it tries to prevent problems. So similar when you drive and you see a semaphore, you have to wait because it's red. I mean, even if nobody's there, you will wait. I mean, if you're not in Italy. Of course. You need to have a red and red. Red is recommendation. No, it's red, but it's early in the morning. You don't expect some people there. You can drive. Red is, I know, peak traffic, and basically you can kill. SQL Server prevents problems by locking. So you are not able to change something which I read right now. When I finish with reading, you can change. If you change this, I have to wait. If we change both, try to change the same row, we have some of us has to wait. This is basically how SQL Server works. And this is when you have a lot of threads, a lot of concurrent sessions, a lot of transactions. This is basically a bottleneck. This is exactly a case where I know 2 match logs and I don't have a lot of conflicts. You know, I always drive here, borders come later, I know this, and we will never actually cross this. And basically, I have to wait, why he has to wait, basically, and you don't have a choice. You can have a choice from blocking point of view, to use no lock, do not lock. But there's an additional type of locks, sledge. This is a physical thing. You cannot take no latch. So this is a physical thing, this is protection of the memory, in memory buffer, just allow that not several threads touch the same thing at the same time. And if you don't have a lot of concurrent sessions, you don't care about it. I mean, this is something which exists and it's not so big problem per design. But if you have a lot of sessions, this is exactly the reason why I slow down. And in this case, this can help. Native store procedure have a lot of limitations. We will see them now. And native compiled store procedure can access only memory tables. There is no way with compiled procedure to access this table. This is not supported. Why at all? Maybe you will slightly change your code. If you refer to locking behavior, if your code is with tab lock, with X lock, that will not work. Because SQL in-memory LTP is lock-free. That will not work at all. If you have a merge and your table OLTP is target, it will not work. There's no truncate table. You have to delete it. And basically, this could be a challenge too. You cannot make cross-database queries. You cannot put select from database.dbo or something. It will not work. You can easily make a workaround. You put this in table variable and then work with it. But I mean, you have to write some code. There's no support for link servers. This is for all, for Transact SQL touching in-memory LTP. This is native compiled store procedure. I mean, from cool this thing we did only this line, and I have to put with native compilation, schema binding, execute as owner, as begin atomic with a lot of things, and language. I mean, I don't need language. This table is 2 IDs, but why I need language and such things? Why I have to put everything here in create procedure? Why he requests from me some language or execute? Who will execute? Why do you care who will execute? Doesn't matter. We don't need to put it in normal store procedures.
Because of blocking.
Sorry?
Because of blocking.
Blocking. No, mate, that will not lock definitely, but basically you can write the same procedure, touching the same table in memory, but not native, it will not be locked. Whenever I ask something why in OLTP, you can always try with the answer because of speed. So everything, if I don't specify execute as owner, if I specify execute as caller, SQL Server has to find out who called this procedure. And again, you can do this efficiently, but again, it's better not to do it at all. And do you have rights for it? Just go to security, see this. And schema binding, if you don't have this, what would happen? You could change table structure of this, and this will allow, it will be allowed with this. And then if it's a change table structure, you have to check. Did someone change table in the meantime? And this is basically small overhead. If you put it, no changes. If you, for some reason, need some to do something with text, you just put some language. Whatever this regional settings, I don't know, interpretation of dates, what would be in this case, you have to put here. And you can here put some number of some existing account too. It doesn't need to be owner. You can put some specific account. And this is basically on the compile time executed. In normal in old store procedure, this store procedure, you create store procedure and nothing happens. It's basically just save definition and nothing. The execution plan is created when you execute it. Here, the execution plan is created immediately when you create it. Because everything it needs, it's here. And there's no changes. And of course, there is no alter. I mean, you have to drop it and create it again. Okay, no alter, it's atomic. That means the whole procedure is one transaction. This is not the case in all in this procedure. Compile to DLL. There is some statistic issue. I have to skip it now because I'm late. So, you cannot use left join. If you like left join, sorry, you have to use inner join. And, I had a couple of developers who just heard that inner join is faster than left join and just convert left join to inner join. So, of course, you will not do this. Subqueries, if you need subqueries, I'm sorry, are not supported. If you want to play with operator, you can play with and between. If you need or, žalim slučaj. If it's correct pronounced in Bulgarian. It's not possible. Distinct. Top with ties of percent. Only top. It's optimized for unknown, always. So, a lot of limitations. Some of them because of first version, some of them by design. So, some tips how to use it, and especially when I put my shadow here, you can even not see this slide. But you can download it. So the whole thing about in-memory OTP is about transaction. So they are now, there's no locking. That means they allow me to drive and Boris to drive. And we can have a collision. So if your workload is such that collisions are possible or frequent, you should not use Hekaton. Because with this locking thing, from development perspective, it's a good thing. I just wrote the code, and it's done. And everything is basically done by database engine. You have to lock, has to wait after you're finished. It's release lock, and this process can wait. And as developer, I do nothing. I just write the code update, and this is somehow done by the engine. Now, when you allow both of us to do the same thing at the same time, you can even update the same row at the same time from different sessions. Sounds dangerous. It is. So, how this looks like? Right. This is conflict. Of course, we still have ACID. We still have consistency. So it's not something total anarchy. So that will be fast. Of course, you just put and you just update. I update you don't know, and it will work. But so there is a mechanism that detect that something happened. They allow you to work. You should not wait from the beginning. So if you don't have a conflict, you proceed without waits. This is what we want to have. At the same time, I want to detect conflicts, of course. I want to still be consistent. I don't want just to be fast. We still have some consistency issues. And similar to what? What is similar to this scenario in these tables? When you see such things? When is deadlock? It's the same scenario as deadlock in OLTP. You get the deadlock, you get something, some stupid message like, you have chosen to be a victim. It's missing only congratulations. Your session has been chosen as victim of this. In this case, similar. And now, depending on transaction levels, we have 3 of them. And as you guessed, we will not cover them. So, I have screenshots for them. You have different errors similar to deadlock. And you have to deal with them similar to deadlock. How to deal with them? What you do when you have a deadlock? What is the best option for development?
Retry.
Sorry?
Retries.
Retry. The others? What's the best option for developer? Do nothing.
Code developer or is it
Do nothing. Just ignore it.
developer
Sorry?
the code developer just writes a no log. The SQL developer
Yes, I mean, no log, but could mean some changes in business logic. You're not allowed to put risk in business logic. Deadlock is an issue, but you cannot solve the issue in that way that you just make risk for business logic. It could be. Sometimes with no log you can solve the deadlock, but you just now you try to solve the deadlock, right? But the best option, do nothing or ignore deadlock. And this is a valid, legitimate option. Some deadlocks, I don't know, if deadlock happens once per month, who cares? This is the same issue here. You have two transactions. I don't care. I just don't need to retry again. Of course, the first thing, if you really need to check this, is retry mechanism. If you have a misfortune, basically that you are a victim of this, try again. And if this transaction is short, you will proceed again. So similar to deadlock. That means in memory LTP you have to do something. If you have conflicts, you have to write a code. In these tables, in this pessimistic model, you don't need to write the code. It's handled by the engine. So this is not totally free. That's the great thing. It's in the middle and nothing. Let's see. Here is a list of errors, and basically, I don't know how this looks like. Show, yeah. Here, if error number in blah blah blah, wait for delay 1 millisecond and try again. Why 1 millisecond? Because I expect that these sessions the transactions are short. You do one operation, and that's exactly use case for Hekaton. If you want to get 10 million rows, you should not use Hekaton at all. This is cluster column store and source. And let's say, by design, you can imagine that the future could be Hekaton plus cluster column store. That this table will disappear. Either you have, if you need the storage, you cluster, compression, whatever, and hot tables in Hekaton somehow. Okay. Again, transaction. So each transaction has how SQL Server works. Allow us to proceed and then have some validation phase to check the SQLs, the overhead. But again, if you have a lot of conflicts, and that depends on your workload, then it's not Hekaton is not for you. A lot of exceptions, of course, it's not a good thing. You have to handle it, have to wait, retry, try again, wait. I mean, it's more expensive. If you have few collisions, few exceptions, that's okay. Okay, you have even memory optimized table variables. I mean, and you can use them sometimes to work around some missing features like cross-data disappearance and so on. So, in-memory OTP tables, native compiled store procedure, and in-memory table variables. Yep.
Speaking of the compiled store procedures, unfortunately you said that the plan is maybe the estimated plan is compiled with but do you have any problems with parameter sniffing?
No, there's no problem with parameter sniffing because they have implemented what? If you don't have problem with parameter sniffing, that means it's disabled. And how we disable parameter sniffing? By specifying optimized for unknown. So internally, each store procedure is optimized for unknown, and there is no parameter sniffing problem. That means the plan is not optimal always, but it's consistent. Okay, summary. Multi-version control system, no latching, no locking, everything fast, everything fast. That means you have to pay some penalties. If you don't have problem with speed, do not consider Hekaton. Just if you think about my application maybe will be faster if I just move this table to Hekaton, you should not do this. Because if you see that it's faster, it could be a little bit faster. So it is extreme fast when you have a lot of concurrency. If you make I don't have a demo here to show you how to deal with it. I wanted to demonstrate this session state server. I'm not able to demonstrate this on notebook. And it's a server, massive server connection. It's very hard to demonstrate this. You need really a lot of transactions, a lot of concurrent sessions. You have to have a lot of things to demonstrate this. If you don't have serious problems, it's not. But everything is about speed. You have to consider transaction limitations. How to deal with it? How to deal? There is no virtual max. you have to put about just 7,000 and to put this in chunks and then to restore this. You have to do something, and everything is in memory. That means you have to, if you don't have a memory, you have to buy it. So it's not free. No weights, but you have exceptions. You have to deal with this if and such things. It's not a big deal, but you have to write. If you have 10 and 100 stored procedure, you have 100 times to write this and to test this again. So I mean, someone has to test this. In-memory OLTP use cases. First case number 1, BVIN, session state management, high data rate, data insert rate, and all these use cases are described here in this document. You can get it and you can see how they, what's the problem with this, how they change this, and you can see company who implemented this. I can guarantee for BVIN that all data that we provide there are really true because I saw them in Bradmore. We made in this lab and I saw 250,000 requests per second in CTP2. We will count this number later. Okay. High data insert rate. I have implemented this 2 weeks ago. This is an issue when you have a lot of transactions per second. And you have suddenly a lot of rows to insert. Usually you insert, let's say, 100 rows per second. But suddenly you have to insert 40,000 per second. This is a shock for the system. It's too much. And basically, because of this, usually these inserts touch the same page. In this balance tree, if you want to think about structure of data, you target the same pages. All parallel threads wants to write on the same page. You have a whole system here, but everyone wants to write here because usually you have identity as primary key or sequence or something. And basically, you are limited now with this latching. You cannot insert 40,000, you can insert 10,000, and then you have weights. If these weights are part of SLA, then you can have problems. For instance, in BVIN, if you need 2 seconds to write some information and someone score in a game, you can make a bet that someone will score after you saw that he scored, and if you just reach within these 2 seconds, you can win some money. It's sure bet. So this is basically risk, which SLA, if I miss something like this could happen. So if this 40,000 I cannot insert, I have to somehow find a way to do this. So in this case, we just, put this data not on disk, but in Hekaton table, and then with another process, put it in this table. I have implemented this in 4 hours. I mean, I'm not still sure if this number will fit, if I pick the right number, but it's not a big deal. So you can use this, take this to me, this is similar when I come home and my children have a lot of toys in the street, or when I go to supermarket and my wife just bring me 10 how to say this?
Bags.
Yes, thanks. 10 bags at the same time, I have to deal with this. I'm shock absorber then, and she wants to buy another thing. So this is here, you just put in memory LTP, it's fast, it's log-free, and then put it in this table. In my case, I put it in cluster column store table. So this is an option you can use. Some kind of hot call scenario. If you need something to be fast, very fast, written somewhere, just put it in memory and then later, but you have to write your own procedure to move data. Delete from Hekaton, output in cluster column store. Okay, compute heavy data processing is, then you have a store procedure which is not which execution plan is not reused. You have to compile again. And then when you call something 10,000 times per second and have to compile, you have some penalties there for compilation. Then, because SQL is interpreted language, if you put this in compile store procedure, you get immediately DLL. You don't need to interpret. This is similar change as if you are a .NET developer between ASP, which is fully interpreted. You see if and just basically create some kind of program for your interpretation, and here's basically completely. So with native store procedure, you can solve this problem. course, it's very challenging how to write this procedure. If your system is complicated, it would be better to use native compiler. On the other side, if your system is complicated, you will have a lot of things which are not supported in stored procedures. Within next weeks, you can expect some workarounds for how to work around left join, how to do something like this. There is already something. Okay. Let's see. Watches. In the meantime, my wife. She watched me somehow. And my wife called me 2 minutes ago. I mean, we are everybody watching us here. We are somewhere. I mean, I cannot imagine it. Demo ASP.NET Session State Server BVIN. So, what is... before I start with this, I will just put credits for my colleagues. Wolfgang Kuchera, Biljana Lazic, and Richard Polosek. They have implemented this. I did not implement it. I just present this and I just tell they have implemented it. I was not in the company as they implemented this. They have implemented this even before SQL Server comes with CTP1. We have a special relation with Microsoft, and we have some. This is some kind of feature ordered by BV. So this exactly what we need. This is hackathon. You know, when you have a ball and you're a player and you have a ball here and this is a volley. I mean, exactly what I need is coming with this feature. So I don't need to consider something. I just wait for you to deliver this feature. I will implement it immediately. That's the reason why we have implemented before public version, before RTM, because we know what we expected. So, what is ASP.NET ISP State Server? When you have a web application, this web, and when you have a user session, of course you want to save everything user write, I know, check, do every click to save in this session. When you have a fallback to server, you want to return this information to server, of course. In SQL Server, in IIS, you have an option to save this information to the server itself. And when you hit the server again, it's restored and you can continue to work without a need to put this again. Of course, when you have a lot of servers, when you have a lot of users, you cannot reach them with one server. You can put web farm, you can put 4 servers, 8 servers, whatever you need. And then it's not guaranteed which server you will get by next round trip. If you get the wrong server, you have to log in again. And of course, this is not acceptable. And then the solution is to make a shared storage for it. And shared storage in Microsoft Word is Microsoft SQL Server, and Microsoft even delivers solution ASP Session State Server is Microsoft product. If this is slow, this is Microsoft. You have to blame Microsoft. And this works perfect for a lot of companies. And for BV, that works pretty good. Up to some values. You have a high number of short transactions. You go there, you have a session ID for each session, some GUID. Go there, update this session, and then come again. And you have to do this with a lot of customers. And of course, my company wants to have a lot of customers, a lot of players, to get money. And you cannot get more players because we cannot support it. The worst thing for IT people is that they cannot support traffic or workload that is basically done by management, by marketing people. They got players, they got some bonus, players are satisfied, they want to play, and say, first 1,000 can play and next one can wait. You can't do this if you're only one. But you have a lot of other companies, and if these companies solve this problem, you will lose your customers. So, let's go to numbers. This is just simulation. How this... I'm wrong. Why would you tell me that I'm wrong? So, what happened? Whenever you go, make a round trip, you have to get to read session, because this is not on yours, it's on server. This is HTTP's stateless protocol. You don't have any information, you have to get it. And this is, you have a lock here. You get this, it's short lock. It's not a big deal. It's not 5 seconds, of course. But if you have 10,000 requests per second, then basic SQL Server has to manage all these small blocks. And then you update this information. I choose something, I choose language, I do something, layout change or whatever. and you have to go back to the server. And of course, if you have a lot of requests, then you have to need a lot of servers to communicate with this. Up to some number of requests, you cannot proceed this anymore. Because the same thing, all these threads touch the same page. And up to some number of requests, you cannot manage it anymore. And here are numbers. This is the page. This is a screenshot because if I would execute this here, it will not be allowed because we don't have a license for Bulgaria, so it's not possible. Here, this screenshot is not hacking. So this page, when you think about 10,000 requests per second, it's too much. But it doesn't mean 10,000 players a second that you make that. That means 10,000 requests. And one page, like this, doesn't have one request. There's a lot of requests in background with server. This service is one request. Yeah, we can hear something like bestseller, what people play today. The marketing guys want to put something here that comes from the other system. You have a lot of communications. These communications nowadays, they try to encapsulate in Ajax, that the user doesn't have perception that something is basically round trip. And this is actually round trip then to communication, web request. If you put here some bet here, by the way, this match was 1-12. 12-1 for Southport against my club. So this is something that you have to expect to be persistent between clicks, and you don't have any clue that some clicks happen in the background. So this page usually produces about 100 requests per second, only for this page. And this will be in future no more complicated. Just put it here, make it. And we can do this here, do this here, do this here. Flash, it's not. With Ajax, it's feasible. That means one page can be 100 requests per second. That means it's not a big deal. It's not. It's feasible to get 20,000 requests per second. So we can support 10,000 batches per second. The default solution from Microsoft, 10,000. With some implementation of reverse index in assembler, we could make this about 15,000. More than 50,000, no way. And what happens after when you have 15,000? Suddenly, everything is first slow. When something is slow, what is the first reaction of the user? Except some, I don't know, vulgar words against the company. What's the first reaction? No. Click. Click again. 14 years ago I married such user. When my wife doesn't get something within 0.1 seconds, she clicks again. Maybe this will help. Of course, if you don't get something, you click again, the thing is worse. You just put additional thing in queue, and basically the problems are exponential. So after 15,000 doesn't work anymore. After a few minutes you don't have anything. That means you have to kill all the sessions and basically restart the server. So this is, of course, not acceptable. We cannot restart the server. Then we have to put to make some partition. If you cannot serve 10,000 requests and you can 5, you then put 2 servers and basically handle 2 servers. We have to put 18 servers. Geographically. For Belgium, for I don't know, for this, and to maintain them. To come servers back, you have to do this 18 times. If you need mirroring or availability group, 18 times. That means for DBA, one DBA just manage the servers. It's very expensive. And you have to pay licenses for them. Okay, but as you expect, we have implemented Hekaton. Okay, this is a typical scenario. So whenever, in session state, we have such queries like select star from table where ID equals something. Update table where equals ID equals something. 99% of queries are such like this. We don't have a range. Could you give me some requests from March 2014 in session state? We don't have such requests. It's highly optimized. Point lookup. We always want to get one row and to save one row. And that's the reason why an ideal scenario for this. And I want this to be fast. And we don't have a conflicts because I don't have a session, two parallel sessions of the same session ID. I have only a lot of sessions which are not in conflict per ID. They are in conflict by technology. They cannot serve this anymore. And okay, we have changed this table, and this is original table. You should not, this is not my table, so if you think that something is wrong, tell us to Microsoft. So I have to change it and to hackatonize this table. And first thing is to put something like this. If you want to deal with strings, well, you have to put some binary to collation. Why?
It's fast.
It's fast, exactly. So if you compare binary collations, you don't need to worry about accents, about the other things, it's faster. So I just took this one. This is RTM version, so default constraints are supported. Image or nvarchar max, varchar max is not supported. And instead of this, I just put a bit. That means I don't need this information. And of course, it's fast. And primary key cluster, there is no cluster index in TP. I have to put non-clustered hash, pick some number, random, and put this in memory, blah, blah, blah. Schema only. Schema only is decision that if we lose this data, I don't care. So I'm not someone who is responsible. I don't care. But I don't care is something, worst case, in worst case, if we lose a session, that means that the player has to log in again. This is not something which makes the player satisfied, but it's not a big deal. It's not tragic. We don't lose a bet. We just lose what? Yep.
I think you said a minute ago that you wouldn't have conflicts with the session IDs if the page generates.
Someone heard what I think. What I thought. Yes, we don't have a conflict. It's not a conflict. But if we have a crash with, if data disappear, if this session is not anymore, or if we somehow lose, we will catch it. If I don't react on retry, for instance, if I lose some update, if I lose something, it's not tragic. It happens today. We have every 2 or 3 days someone has to log in again. This is acceptable from business point of view. I don't need to fight and to spend another 3 months to try out to avoid this. This is not so expensive.
And the reason is because conflicts, concurrent writes.
The reason could be because we could have sometimes race condition between write and read, and this could happen. We have a retry mechanism implemented.
Not at all.
Yeah, sometimes can something happen, but it's basically it's okay for me. Even if I lose the whole data, it's still acceptable. It's not tragic. I don't lose money directly. And if I here use schema and data, that will not be so fast. And basically, I just choose okay. I would take this. I will pay this price. Someone can log in again, but I will have a great performance here. Okay, so because we cannot support. nvarchar max, I have to put this in chunks. 7,000, and I have here session part, and this basically I just put in chunks in order to be able to restore the full information. So this is some kind of workaround because it's not supported. It's not a big deal. Few days with test, everything goes fine. Again, here are numbers. It's real number. 458,000 batches per second. What you can find in video about Bivin and Hekaton is 250 because it was in CTP2 time. I was in Redmond this time, I saw this 250. To be honest, I did not see this immediately. They told me this is in RTM later, but I trust them. And that means 15,000, now 450,000. And you can tell, you will never have 450,000 users per second. Yes, I will not have, I don't expect such expansion of online betting, but if my page is complicated, I will have more requests per user. So we are supported with this with only one server. Yep, here is marketing graphic. SQL 2014, number of requests. This is original, and this is basically tuned with our action. So number of requests per second. What does it mean? If I can support a lot of things, what is additional benefit for me? I had 18 servers because I had to support. Now I don't need 18 servers. It's interesting, especially for people who have to pay licenses. Only one server. Instead of 18 servers, only one server. And license codes, fetching, you can use this software for something else. It's only one thing. Less work for DBS as developer, I don't care for their workloads. But this is a fact. They can do something else, or they can read newspaper, or they, I don't know. But this is not directly because it's a challenge for development. That means I don't care, but just to be fair, there's also some kind of parameter you can use, and we scale back. It means I get more requests. Okay, I got a new version, I had to pay some licenses, but at the same time I replaced 18 servers with one server. To scale back and get something is, I don't know, perpetuum mobile. Okay, good. That was pattern B. And you can find here on this, Microsoft already created a new version with in-memory session state server. Yep.
Was it to support replication and failover?
It is supported. It is supported in availability group, and it's supported failover. I have asked DBS, these guys who, I don't care what they do. I have asked them.
Replication as well?
Replication, I don't know.
I would be doubtful.
We have a failover, and for availability group is all this server is mirrored with the availability group. We had switched in this, but basically, yep.
Is there a way to predict how much space we will use for a table in memory? Is there some comparison tool or something?
How much memory you would need?
Yeah.
Yes, there is some kind of, you can calculate, even I don't have it here, but I can send you a link in MSDN. There is some kind of calculation how many memory you would need. The tricky thing with this is that you need memory not only for actual number of rows. You have to think how many rows I would have in worst case. And then in addition to this, you have to think how many times one row in average will be changed within one transaction. It means because of this, how SQL Server detects conflict can allow me to change at the same time with someone else, both versions of memory. So if you change a lot of times the same row, you need to calculate this. I mean, one row which is not active and one row which is active is basically the same space, the same amount of bytes needed in memory. So you need to consider this, you need to consider size of indexes, and you need to consider it's somehow possible to calculate if you know how many rows you would expect there. If you miss this number, of course, the full calculation is, and you need to put a little bit more, of course, for it. Okay, should I use in-memory OTP? Should I tell it as well? Oh. I should finish. Okay, give me just 2 minutes. So, should I use in-memory OTP is the question for each developer. Now, okay, I know something, there is some feature, should I use it? How to do this? You should analyze this application. Again, do you have problem with speed? Yes, no, do you have a lot of concurrent session? If you don't have such a thing, just take time to do something else in SQL Server. Everyone has a lot of problems, performance tuning, dynamo, statistic, whatever, but this is not topic, or still not topic for you. Just identify hot tables and bottlenecks. I mean, you don't need to move the whole database. Just take and try. It's not a big deal to try. It's not few hours, few days. Just take hot tables. There are tools that can help you. Then consider feasibility and constraints imposed. Are you able, with these limitations, to do this? Do you really need to be locked? If something needs to be locked, you cannot do this in Hekaton. You can forget it. If you rely on this feature, then see cost. I mean, do I need to change 200 store procedures. And then you have to find out, it's really worth, should I expect something with this? Should I take, it can take three months. It is basically the question, should I do this or not? And then iterative implementation. Just try one table, two tables in first step, then you can change native compile, and then, of course, performance comparison. You have to find out the way if it's better or not. Just make baseline and this. What can help you are some tools here. You can have analyze SQL 2014 IMR tool. It's basically some right click in each table. You click right, you can see if this table can be hackathonized, and if not, what is hackathonized blocker. You can see some advices. And this tool can help you to analyze your workload. You can execute it against 2012, of course. Otherwise, it doesn't make sense if I migrate 2014 just to think what is possible. In 2012, you can, or 2008, execute this and to find out if this would be possible or not. And then would this be, they get some estimation, it would be 4 times faster. And at the same time, you have a cost. Do you need a lot of time to change? Fortunately, I have to finish now, otherwise someone will kill me who speak after that. If you have some question right now, if not, you can find me here somewhere on the floor. Thank you very much.